My name's Phil Smith. I'm a sysadmin from Melbourne. I currently work for a personal care manufacturer doing shampoo, cleaning products and so forth. My previous role was in managed security with clients like Toyota and BMW. Private schools, local governments, a lot of that around Australia and New Zealand. Outside that, you'll find me at the fire station or out four-wheel driving, making a mess of the car. And in my current role, I've spent the last 3 years or so implementing Dualstack throughout our whole network. There's no real push. There's no problems I'm solving. It's just that it needs to happen, so I may as well do it now. So, some Google IPv6 statistics from Google. There's nothing too surprising there. USA is at 5.29% of Google traffic, Germany at 5.66%. Peru, interestingly, at 4.49%, and apparently the reason for that is the incumbent over there, Telefonica, selected Peru back in June as a deployment for IPv6, much like Internode have done for their customers in Australia, deploying Dualstack by default. Apparently that's what they've done for Peru, so that accounts for their high usage there. Unfortunately, Australia's been beaten by New Zealand by 0.33%, so Australia, come on. If we zoom into Europe though, highest uptake is Switzerland at 9.51%, and number two is our old friend Romania, 7.36%. Who's had exploratory traffic coming into the network from Romania? Anyone actually had a compromise from Romania?
So the Romanians actually have a problem. They have a bunch of IPs allocated internally and no routing.
Okay, fair enough.
Not likely to get compromises from there yet.
Well, I have had an IPv4 one before at a previous job. So who here is running IPv6? Nice. Who's not running IPv6? Have you read this first before you put your hand up? I don't know if you can see it properly there. Basically, if you think you're not running IPv6, you still might be. So far we've determined that Romania is a leader in IPv6 and you're probably running v6. So what are the challenges around that? When it comes to firewalling, who's got time to do this all the time? One person out of however many are sitting here. It's repetitive and, sorry, it's hard. If it's hard, it won't get done. It's also repetitive. If it's repetitive, we need to script it. So, enter stage left, husk. Husk is a wrapper around netfilter and iptables. Sorry, netfilter, which is iptables / IP6 tables. Has IPv6 support, it's written in Perl. If you look at the code and you know anything about Perl, I know I'm not great with Perl, but I've managed to make it work. It's only got two dependencies on purpose. There's two Perl modules that it depends on, apart from the obvious netfilter stuff. And that's done on purpose. Those modules are packaged for Debian and Red Hat, and it just makes it easy to install. It's got a custom DSL, which I'll cover shortly. It fails safe. And by safe, I don't mean it leaves your system wide open. If something's wrong, it will by default log and drop. There's hooks if you're running things like fail to ban, so you can manage your firewall and then have these hooks to actually restart fail to bans and so forth to put those rules that it needs to work back in. And there's helpers just to make life easier. What Husk is not, it's not a complete abstraction, so if you don't know anything about netfilter, don't know anything about iptables, maybe you want to read up on a little bit of it first. It's not fully automatic and it's not incremental. It will always do a deterministic and complete build of the firewall whenever you run it. Fun fact, this is my production Dualstack firewall at work on our perimeter. 2,540 rules managed in only 796 lines of configuration. And that makes me happy face. Where are we here? Custom DSL. So one of the goals for Husk when I wrote it was to have a human-readable and flexible language to be able to use it. So in our examples here, your regular iptables command might be -a for append input, interface eth0, protocol TCP, dport 80, wait I need 2 minuses in there, and j accept. To do the same rule in husk, it's just accept, in net, protocol TCP, port HTTP. It's human readable, it's flexible, I don't care what order you put them in, as long as your keywords match up. You can't say protocol HTTP, port TCP. As long as it matches up there, it works fine. So it's basically your action is your first keyword, and then your criteria follows after that. Another example, drop in net source address microsoft.com, if that's something you want to put in your firewall, and the corresponding underneath it. Another example, multiports. I don't care for manually having to remember to load the multiport module when I'm doing a rule. So all I need to do is tell husk that, hey, plural ports, do that, and it will take care of it. NAT becomes a lot simpler. So instead of all this having to worry about what table we're in, we just map in net protocol TCP, port HTTP to whatever the address we want. And lastly, like I said, it doesn't assume that you still need to know a little bit about iptables underneath. If you want to do something special, hacky, that's not fully supported, you can still throw in your raw iptables commands and have them just compile as part of the rest of the rule set. I put that in for the SNAT. SNAT by default in husk will only SNAT your RFC 1918 addresses. If it won't SNAT public addresses. So if you do actually want to SNAT a public address, for example, this 150 address, you'll need to do some little hackery in there. Zones. So each interface gets a nice name. It's just nicer that way. Instead of having PPP0, I actually call it net. That's my internet connection. I'll refer to it as that. It also makes changes easier. I've got to change one config file and say, actually, I'm changing providers. PPP1's now my net. Recompile the firewall. Done. I don't have to worry about every instance of where I've used that throughout the rule set. Helpers. Built-in helpers. So there's a NAT helper. Apply outbound traffic from a zone. So you'd say common NAT net. And any traffic going out that interface from a private address will be source netted. Bogon, drop your Bogon traffic for IPv4 and IPv6. So your 1918, your CGN, carrier grade net, and so forth. Port scanning, common port scanning patterns, Xmas, Christmas tree packets. So they're not comprehensive, they're just some dumb helpers to go along with it. Some other ones in there, spoof protections to make sure that you're only seeing traffic in the zones that you expect. So if you know your LAN is 192.168.0.0/24, your spoof rule will make sure any traffic from other addresses just gets dropped before it gets any further. Custom helpers, they're external to husk and stored in files and need to be included. There's various helpers that come with it. I'll go through the include shortly. Active Directory, GoToMeeting, DNS, email, ICMP rate limiting, so forth. They're just basically pre-written rules for common uses. GoToMeeting was one that I had issues with at one stage because they do have a good documentation on there, what firewall rules you need to let GoToMeeting work, but you've got to actually put them in. So instead of having to write that every time now, I can just say GoToMeeting, source address, whatever computer needs it. Simple example. So we define rules that says SSH OK, accept source address example.com, then on our input chain, SSH OK, protocol TCP, port SSH. So this is defining your input chain. First rule, protocol TCP, port SSH will jump to the SSH OK rules, and then accept example.com. Remember I said that it fails safe, so log and drop by default. So we need to specify, even in your output, need to put in an accept all, otherwise the default will be to log and drop. Apart from state, your related and established connect traffic is always allowed. So you don't need to worry about that. These are only dealing with new connections. Another example for a router, this is where we bring in the concept of zones more. So you can actually have a relationship in your rule sets between your zones. So previously we just had a single string as a name for a set of rules. Now we're actually saying from this zone to this zone, apply these rules. And the examples that go with it. Again, the multiport example there, just by adding on the plural to the ports. And this is an example of using a helper. So inside the helper, and I've actually missed it on that, I apologise. Up the top there should be an include directive there to include the DNS helper, and which basically it's just two rules to accept UDP and TCP port 53. So instead of having to have two rules here, I just say DNS going to my name server 1. So where does IPv6 come into this? It's really easy. All you've got to do is add in the keywords. So first example up there, we're adding, for SSH, we want to accept both IPv4 and IPv6 from the host example.com. Obviously that's relying on DNS, so as long as you're publishing an A and a quad A record for example.com, that will just compile as you expect. Second one there, we're saying this is only an IPv4 rule, so only in IP tables from source address 192, blah, blah, blah. And then the same again for an IPv6 address. IP both, again, because there's no addresses in this rule here, so there's no reason we can't just say IP both for TCP port 22. And then again for the fail-safe, accept IP both. If you forget that, then you're going to have your accept all on IPv4 and not on IPv6. Yes?
Can you set IP both default?
Sorry?
Can you set IP both as default so that you don't have to...
I vaguely recall putting something like that in, but I think at the moment it only defaults to IPv4, just because that's the most common use case.
Question, would it be, or is there already efforts in the direction of providing objects, such that I can say web server and then define my...
Variables are supported, yes. I did not include them though, but I'll talk to you after you.
Do they work?
Sorry? Oh, sorry, the question was, is there support for objects like define web server and then say web server?
Like a variable that is evaluated in an IPv4 content differently than a context differently than it would be evaluated in an IPv6 context, so that you can store your, similar to what DNS is doing, except you want to have it in your configuration and not in DNS.
Interesting concept, hadn't thought of it. So no, but I like it. I'll look into that. What are we up to next? Adding IPv6. Again, more examples there. We'll go through that. Applying changes, it comes with a little helper. It's really simple. So there's a script called fire. We'll compile your rule set into a restore script, save the current rule set, test load the new set. If it doesn't load, it will revert to your old rules. If it does load, confirms that you can still establish connections to the machine. That has a timeout on it. If you can't actually push yes, because something's wrong, it will time out and revert back. If you hit no, if you hit no on purpose, it will revert back. If you hit yes, then it says, thank you, come again, tells you how many rules it's loaded, and you go on your merry way back to whatever you were doing. These are all logged into syslog as well, so you can see when people are applying firewall rules. You can audit when the rules are being recompiled and applied to the system. So, go forth, IPv6, firewall it, and any other questions? Yes?
Have you looked at extending it to support MP tables?
Have I looked at expanding it to support
MP tables.
MP tables?
Replacement framework for IP tables and the latest stuff.
Was not aware, but no. Conceptually, I would like to expand it to support other frameworks. My thoughts on that were originally around the PF firewall and so forth for BSDs and so forth, but I'll look into that stuff. Yes?
What other packages did you look at before you decided to write your own? One that comes to mind is UFW. I don't know if that does IPv6.
When I started this, UFW was very immature, to the point that I don't think I was actually aware of UFW. And there is actually a bit of background around the DSL of why I did write it to pass that particular language code. But no, and yes, there's Shorewall, there's UFW, there's all the other ones. It just came down to basically, they didn't suit me. There's nothing particularly wrong with them. They just didn't suit me, so I rolled my own. One? No more. Okay, thank you.
We can take a couple more questions while we're setting up.